Okay, next we are going to touch on converting graphs. Okay, previously you have learned three types of graph, namely distance time, speed time, and acceleration time. Okay, so look at the two charts that are given to you. Okay, we have the three types of graph arranged in first, second, and third level. Okay, on its right, we have a few different shape of different graph, and with this I'm going to touch on how to converting distance time graph to speed, speed to acceleration, and vice versa. Now, for example, if we are given a speed time graph as follows, how are we going to change the speed time graph to distance time or acceleration time graph? Now, look at the speed time graph. It is a second level graph type. So let's start by converting speed time to acceleration time graph first. In the next slide, you see that we have clearly three different portions in the speed time graph. Okay, portion A is increasing, portion B is at a constant speed, and portion C is at a decreasing speed. How are we going to change that to an acceleration time graph? Okay, observe that for the first part of the speed time graph is a straight line going upwards. So from speed to acceleration is actually traveling from the second level to the third level, and the direction is traveling downwards. So if we look at the chart on the right, we see that from the line, it goes one level down, it will become a horizontal line. So that's why you see that for acceleration time graph, you have a horizontal line for part A. Now let's take a look at part B of the graph. Part B of the graph in the speed time is a constant horizontal line. So once again, from speed to acceleration time graph, it's traveling one level down, and we will see that for horizontal line, it's going to be traveling one level down as well to become a horizontal line at 0. And very clearly you see that in acceleration time graph, that would be the part B region. Now for the last part, we see that the speed time graph is also a straight line, but is traveling downwards. So with a downward speed, it's going to be a negative value. So this negative value would translate in acceleration time graph to be a horizontal line that is below the x-axis. So this will be the final result of the acceleration time graph. But what would happen if we translate the speed time graph to the distance time graph? Now similarly, let's look at part A of the speed time graph. In this region, it's a straight line, and in order for speed to become a distance time graph, we are going to move up one level from second level to the first level. So according to the chart on the right, you see that from line to go one level up, it becomes a curve. So that's why we have a curve representing the part A of speed time graph in the distance time graph. And if we slowly move over to part B of the speed time graph, a horizontal line will move one level up to become a straight line. And as it goes on, when the last part of the speed time graph is a straight line but going downwards, so its gradient is negative, which means that the curve that you get in the last part of the distance time graph will be slanting in a different direction, and that's what you get for distance time graph. Okay, please bear in mind that this type of question is going to come out for your O-level, but it will normally appear as the last part of the question. If not, it's going to be in paper 1 as a very short answer question, which constitute to maybe 1 or 2 marks. Nonetheless, it's still as important, so please copy down this example and the 2 charts on top. This will be sufficient for your O-level, and with this, the chapter 2 on graph will be concluded. So I will see you in the next lesson, and we'll be touching on vectors.